I'll share my video. I kept it on in the PPT. I have kept it on, but I have not shared it. Should I share it now or not afterwards only?
No, no, I mean, you just you Zoom video, if you keep it on, your Zoom video, just now you're on. So you keep this Zoom
Sir,
video.
actually, password not required. It is already YouTube
Sir,
live now.
actually, your camera, you can keep it on.
Yeah, camera is on. Camera is on.
Yeah. We
So
will.
keep it on. Don't switch it off, because otherwise on YouTube the speaker is not visible. Like
Sir, can you hear me?
Yeah.
Yes, sir. Now it is YouTube live. So
Okay,
I think
you can start.
Rohini, now we take permission from Honorable President and Honorable General Secretary. You may start.
Okay. So, with permission from everyone, good afternoon, everyone. Welcome to the lecture series on satellite meteorology. And today is the 12th lecture, which will be given by Dr. Baby Simon. This lecture series is being jointly organized by South Asian Meteorological Association, SAMA, and Birla Institute of Technology, BIT, Mesra, India. So, before going for the lecture, I would request Professor Someshwar Das sir to give the welcome address, who is Secretary, SAMA.
Thank you, Dr. Rohini. ABM Professor Tyagi Saab, President of SAMA. Dr. Bhatia Saab, Chairman of the Advisory Panel of the and former ADGM of IMD. Dr. Thaplial, the member of the Advisory Panel of the lecture series, and today's speaker, Dr. Simon. He is also a member of the Advisory Panel of the lecture series. Members of the organizing committee, Dr. Rohini, Dr. Nili, Dr. Mohan Kumar. Distinguished participants from, I don't know how many countries they are now attending, but total registration was from about 60 countries. Ladies and gentlemen, we welcome you once again on behalf of the South Asian Meteorological Association and Birla Institute of Technology, Mesra, India. As you already know, this is the 12th lecture in the series out of the 20 lectures. And today's speaker is a very distinguished speaker, Dr. Simon. He has a lot of experience on satellite meteorology. As you already know, he was working at the Space Application Center of ISRO at Ahmedabad, and has a rich experience in all kinds of applications of satellite in meteorology as well as oceanography. Rest of the things we have already mentioned in the last weeks. Today's speaker, since he is already a part of the advisory committee, and I think we also attended earlier lectures, so I don't have to repeat the structure, the course structure of this lecture series. So I straight away wish you all the best, and then we can go ahead for the next program. On to Dr. Rohini.
Thank you, sir. Now I request Professor Dr. Ajit Tyagi sir, who is President of SAMA, to give his address.
Thank you, Rohini, and welcome to all distinguished participants. Thanks to advisory panel members, Chairman Bhatia Sahab, Baby Simon, Dr. Thaplial, who have structured this online training program on satellite so well that it has received overwhelming response. And we had, I think, very high quality lectures from the eminent scientists from ISRO, SAC, IRS, IMD. So it's a good team of eminent experts who have volunteered to deliver these talks. And now we have this 12th talk. We started with the foundation, then various products, including the RGB product, and Dr. Baby Simon, who had been involved with the INSET, both products and the validation. So he'll be talking about the application of these products, sounding, especially the sounding part. He's a rich experience as an operational satellite meteorologist, scientist, and also as a trainer of UN affiliated courses which are conducted by the SAC for the developing countries. So we are really thankful for Baby Simon, Dr. Simon, to be assisting us in this program and also volunteering to deliver the talks one is today and another one will be followed on the mesoscale systems. So I request all participants to make use of these talks, and also these will be available on YouTube. Please go through if you have to again follow it up, and may take up if any further. You see, we have a question answer session here, of course, but then if some more clarifications are required, please will request our speakers to respond to those also. So make full use of it. It is, I think, a very special opportunity in the field of satellite meteorology to have so many eminent speakers covering almost all aspects of satellite meteorology, fundamentals found to the applications. So it's a rich delivery of lectures. So once again, welcome and thanks to our Dr. Baby Simon, who had undergone an operation. So now is fit. So we are happy to have him. All the best. Thank you.
Thank you.
Thank you, sir. So before going to the lecture, I would request Dr. Mili Ghosh to introduce our speaker.
Thank you, Dr. Rohini. I am sharing my screen first. Thanks for giving me a chance to introduce Dr. Simon. Dr. Simon is the eminent scientist in the field of meteorology and has retired as Scientist G from Atmospheric and Oceanic Sciences Group from SAC ISRO. He has more than 35 years of experience on application of satellite meteorological data for monsoon studies, air-sea interaction, intra-seasonal oscillations of monsoon, monsoon onset, and mesoscale process studies. He began his career with ISRO after his master's in meteorology from Cochin University of Science and Technology, and he held a third rank in that, and a PhD in atmospheric sciences from Berhampur University. He has been involved in the retrieval of application products from INSAT, INSAT 3D, 3DR, and validation of satellite-derived parameters from INSAT at megatropic satellites. He has held several prestigious positions like Deputy Project Director, MT Validation, Project Manager, INSAT 3D, and Application Projects. He has also served as ex-course director and faculty for United Nations affiliated Center for Space Science and Technology Education in Asia and Pacific courses on satellite meteorology and global climate, and has also served as faculty for advanced course on space science and geoinformatics for Gujarat University, and he has been examiners for MTech and PhD students also, PhD thesis. Okay, and he has a list of awards and honors in his name, and some of them are Young Scientist Award, then Invited Talk at FSU, Florida, USA, then ISRO Team Excellence Award in the year 2008. He has published more than 55 research papers in peer-reviewed international journals. He has several memberships like Life Member of Indian Meteorological Society, Life Member of Indian Physics Association, Life Member of Systems for Science and Engineering. And he is also Secretary of Indian Meteorological Society, Ahmedabad chapter. Thanks a lot, Dr. Simon, for being with us today.
Thank you. Thank you.
Yeah.
Okay.
Thank you, Dr. Mili. So now it's our pleasure to invite the speaker.
Yeah.
Sir, you can share your screen. So
Okay, let me see. I'll share my screen.
Okay.
Okay, just hold on. 1 minute. 1 minute. Share my screen. This one. This is the no. Hello.
yes, sir. The green button. Yeah, it is start. Yeah, we can see your desktop.
Okay. Okay.
Yeah, we can see the presentation. You can.
Just hold on. Huh? Okay. You're able to see.
Yes, sir.
Okay. Thank you so much, Ajit Tyagi Saab, Bhatia Saab, Taplial, Someshwar Das and all the people for the nice words. Today, my topic, I'll be talking about IR sounding products from satellites and applications. So I will try to, this lecture, I'll try to say, club some of the application products actually derived from the sounder data. So let me go to the next slide. So the outline of my lecture, I'll be any of this particular because I could not attend the other part. I'll be talking about the sounding channels, derived sounding and similar products. Then geopotential height. Some of the derived products is geopotential height, layer precipitable water vapor, TPW, total precipitable water vapor, and stability indices. Then there is some wind index, microburst index, both the for the micro scale as well as the macro scale, theta E differential, and sounder products application. So all this my whole presentation is based on the temperature and humidity profile, which the SAC has been deriving both from the 3D and 3DR. Unfortunately, 3D sounder application is not working now, and the 3DR is partially also working. So I'll be talking about this thing, how I have done it, and of course this some of the slides are a little old because okay, then I will try to go to so before going to the actual satellite derived parameters. See, if you the importance of this global radio sounding network is very important, because if you see the northern hemisphere, all the yellow spots what you see in the screen, these are the region where you are having a lot of radio sounding network. But of course, when you see the Africa and parts of Amazon and other parts, there are very scant radio sounding observations. Normally on the world global over, normally 0 GMT and 12 GMT are the time when the globe radio sondes are launched. If you see the southern oceans as well as northern ocean, there is very scant number of radio sonde observation, because any NWP model, you require this temperature, humidity profile and other parameters from the observation to go into the model. So this is lacking, and our INSAT temperature humidity profile, which Dr. Taplial would have given. So those point also goes into the NWP models for forecasting the future state of the atmosphere. So I'll be putting a little effort on how to get the temperature, how to get the derived products on the temperature and humidity profile from INSAT 3DR, in fact. So just to have a brief idea about the mesoscale systems, normally it has been defined as 10 to kilometer spatial area, spatial scale, size, according to House, and temporal scale is from hours to day. So few examples of these mesoscale systems I'll be showing how, in fact, I have done it through the MODIS data, which is very good data, which is giving all the temperature, humidity profile and the products at the 5 kilometer resolution. So in other than the INSAT 3DR. So the synoptic scale, any depressions, it lasts for thousands of the area. Spatial scale is 1,000 kilometer and it will last for days to week. Then of course, planetary scale, monsoon and long wave are part of that thing. So before going into the further thing, you should know that a lot of thermodynamic activity does take place within the atmosphere. For example, on the left side, you see a CV cloud, and it is a direct cloud, and then you see an anvil, and probably the base there is a rain. It's also shown. What I am showing is some of the microburst index, which I'll be showing, is basically derived from this some of the tropical thunderstorm clouds, which I'll be showing. Then you are having the both short wave, long wave radiation. These are all would have taken by the earlier classes, so I will not dwell upon it. And basically, you are having latent heat, and sensible heat, and okay, all these parameters are there interacting. These are the physical process which is happening over our atmosphere. So there are various sounders right now. current and sounders. What I put is sounders as well as similar instruments, because MODIS, moderate resolution image spectrometer, is not a sounder, but it is almost having a bandwidth where you get all the temperature and humidity profile, which is again utilized to get the derived products like lifted index, so many other parameters. So GOES, earlier the only sounder was GOES sounder, 18 channels was there, HIRS on board Nova TOVS, the 19 channels were there. Then you are having the AMSU. Right now I understood that AMSU A, AMSU B is not working. Then you are having AIRS, this already Taplial would have taken, AIRS which is having 2378 and IRC 8400 channel for channels, and then 3D, 3DR, and then Megatropics. And I will put one thing, because since I am talking about this physical processes, Megatropics was having a Saphir sensor, which was useful for the humidity, getting the humidity. Then IRC, of course, is on Metop. Then future, you are having this GIFT and GOSAR. And also we are having GISAT, which is going to be future. We unfortunately, 2021, we had GISAT, which was not able, which was launched, but was did not go to the orbit due to some problem in the launch. So then we are having GPS radio, GPS sounder as well as radio occultation for the temperature and humidity profile. So these are some of the thing which you get. Of course, this I will skip because it's already, we might have told by many people. Of course, only to remind you that there is 19 channel sounder, and also the roughly it is 10 kilometer, but what we have is roughly 10 kilometer, 10 to 10 kilometer resolution, all the for the temperature as well as humidity. And of course, you are having these thermal channels 10.2, 11.3, and split window for accurate determination of SST. So just to recap, because I could not attend the earlier lecture, I don't know, all these parameters would have been already explained. So one is OLR, which is indirectly telling about the cloudiness. Then upper troposphere humidity, which is basically from the water vapor channel. Then insolation, SST, and water vapor winds. So in the previous lecture by Ashim, they were asking we are having both the water vapor as well as the cloud vector motion. So without cloud also, from the water vapor gradient, we can get wind. So then QP, quantitative precipitation potential, then pixel scale rain, HE resolution, and then fire, smoke, aerosols, fog, so on. So instead of just to have a brief idea about how the INSAT 3D sounder, I'm more interested. These 14 micrometer channels are basically used for the caudal part of the atmosphere for the temperature profile, CO2 band. Then we are having the water vapor band, 3-level water vapor wind, or we are 3-level water vapor parameters we get from the 3 channels that in the INSAT 3D. Then we are having the carbon dioxide band around 4 for the lower parts of the atmosphere. So similar channels were there in the HIRS, where they were only giving the temperature water vapor in 3 levels, 1000 to 700, 700 to 500, and 500 to 300. But these levels are also at that time, this is very long back, but our sounder is based on this kind of information which you are earlier having, the HIR, high resolution infrared spectrometer from the TOVS on board NOAA. So now this is of course, this is a graph where it is showing the comparison of different infrared sounder channels with the dash vertical bar showing the center frequency for water vapor absorption channel. So basically this goes NOAA IVHR, NOAA HIRS, EPQA, Terra. In Terra and EPQA, there is basically MODIS sensor is there in both 2 satellite, Terra and EPQA. It is very useful for our mesoscale system studies, which I will be talking about. Okay, so this is what thing, and then this is of course the every 30 minutes from the GOES we are getting this brightness temperature, whereby 30 the warmer indicator red. So these kind of things are available from the INSAT 3DR and 3D also. So I'm just going to put an example of this thing. So now going back to the HIRS, one thing I want to tell you that the temperature sounding, which is basically on the upper sensitivity to the temperature, relatively colder portion of the atmosphere, normally around 15 micron. If you see here on the third table, and the other thing, carbon dioxide expression for the lower levels, basically 900 millibar, 700 millibar, and all, you have the 4.2 carbon dioxide absorption band. And see, there is actually also the 9.6 ozone channel. We are having the ozone channel also in the INSAT 3D. And then we are having the window channel also. So these are some of the channels. Then I will skip this because this is of HIRS, which is not required. Now coming back to the Terra, which is similar, which is not exactly a sounding, it is a bandwidth. So there are some channels which is there, which is very useful for the mesoscale studies, as well as for comparison purpose. A few of the mesoscale system which I analyzed using this both Terra and Echo. You are having 2 passes of Terra on this MODIS sensor and 2 times of Echo. So this atmospheric temperature is given in here, that is from 4 micron and all. Then you are having the cirrus cloud water vapor, which is in this place, and then cloud properties also there in the 8 to 7 micron window. And then we are having ozone again 9.6, around 9.6, surface temperature and cloud top altitude, the upper side, the colder parts of the atmosphere. So this is a very good sensor, and most important is this is available for studying the past cases. In fact, this is giving at every 1 kilometer resolution, but in the internet, at every 5 kilometer resolution, it is readily available within a day. So those students who want to experiment with some of the products, you can have this study, use this INSAT. Other than 3DR, you can use this Terra Echo also. So this is again we are having the airs sounding, as previously told, both the ascending and descending paths. So this also give, in fact, for the 3DR validation purpose. Recently, I saw the paper. The airs comparison was done because that's the best way of comparing the 3DR profiles. There was I saw a paper by Gopalakrishnan and Taplial. So where they shown the accuracy of the at the lower level of the 3DR, as well as of the mid-tropospheric level, as well as the upper atmosphere level. In fact, for the pressure, for the sounding products, you should have an accuracy of from 0.5 to 1 degree, which was not there in this. Right now, we are having the INSAT 3DR, it is not there. It is above, it is lower level, it is 1 to 2K. 1.5 above, almost 2K. So that I'll later on tell you. And here is an example of what the layer mean RMS temperature profile, what the solid line is using the retrieval, and the dashed line is regression. So this, why I told you this accuracy, one should have an idea about accuracy. So in the case of the INSAT 3DR, as well as the other airs, the cloud, the cases where the clear cases are there the RMS here is less than 1 kilometer airs. This is 0.5, this red dark one is less than. So this is excellent in way for the as a input to the numerical weather prediction model. So about however the TPW errors or the humidity errors are again slightly higher, up to 25% also. This is in percent. So one should know the accuracy of this, accuracy of the derived temperature products before deriving the derived products. That's why I am emphasizing on this graph, on this particular slide. So for this I will skip. These are some profiles of humidity. This I will skip. And also we had just for continuity sake, we are having an MSMR. We are having some 4-channel microwave sensor on board, where we made an atlas of the specific humidity over the entire globe. They are having 4 channels, that is 10, 80, sorry, 10, 18, 90, 10, 19, 21, and 36, or maybe 6, 10, 19, and 21. So this was also useful. So this is a humidity in gram per kg from 1st to 3rd of August. Or you can see the ITZ clearly. And when comparing the same thing with NSEP data, also we could get we have made an atlas of this thing. It is already published from the MSMR. I was also in the project of the MSMR project. And again, using the total degree water vapor, which you can regress with the near surface air temperature using the bulk aerodynamic presentation, we have computed the latent heat flux again from 16 over the entire globe, and we compared with the NSEP data also. So these are kind of, humidity is one of the important parameter which is useful for all the convection to take place. I'll later on tell you about this thing. Okay. So now let me start with the derived products for the INSAT, because I was involved in the responsible for the algorithm of the all the derived products. As I told you in the beginning of my lecture, the geopotential height is having an important role. So using the hydrostatic approximation, we can calculate the input, because having G also, RD, virtual temperature. Virtual temperature is slightly higher than the actual temperature, 1 plus T, 1 plus Q into T. So it will be slightly higher than log PS by P. This is where the layer thickness, we can have different levels of the geopotential height, right from 40 levels are there, right from 1000 millibar to 0.1 millibar. So this product is also derived. And then why this geopotential height is important? Geopotential height is more important because this show the sources and sinks of air mass. And air mass is a mass of air which is having characteristic temperature and humidity. So this air mass, especially this is useful for the NWP. They normally derive the 500 HPA geopotential height. So the geopotential height is higher over the region of high pressure zone, high pressure. Wherever there is a high pressure, there is a geopotential will be high. So this is important fundamental quantity which is being utilized for the general circulation models, especially in the middle latitude. Because this indicates the large scale Rossby waves. So wherever the location of the geopotential height is, you can in the middle latitude, they are normally used to locate the Rossby waves, and also it is indirectly the first gust atmospheric wind pattern from geostrophic. We are having, and the tropical region is ageostropic, but in the geostrophy, one can, having known the temperature and the thing, one can find out the thermal wind. So it is very useful for that geopotential height. So just to whatever I said just now, you have to only remember that the geopotential height over the high pressure zone is almost high, very high, 500 HPA. Normally in the monsoon, about 10 years or 15, 10 years back, for all our long range prediction of the monsoon, the location of the 500 millimeter ridge is a very important parameter, especially the famous paper by Banerjee in 1978. He has detected the location of the 500 millimeter wind ridge. And let me make it clear. In the month of April, you see two anticyclones sitting over, one in the Arabian Sea, one in the Bay of Bengal. And this is that 500 HPA streamline charts are the wind are shown, and the locus connecting these two high pressure zones is the, you can say, ridge. So okay, that I will tell you later on. Okay, now just to this I'll be talking about the 500 millimeter ridge, just to have an idea how the changes or the inaccuracy in the delta T of the temperature derived can lead to see this first column is delta T, 0.5, 1 degree error. So whatever it is, and then if you see 500 millibar, a 0.5 change in the temperature, actual temperature, will produce a 10-meter error in the 500 HPA. 500 HPA. That's the geophysical height will be around 10-meter less. But if you go for up to 2 degree, it will be around 40 meters difference. So you have to keep all these things depend upon this. Actually, the temperature and humidity profile accuracy normally required for the derived products is of the order of 0.5 to 1 degree, as you see in airs and other parameters. But of course, 1.5 also one can take. So this is this kind of accuracy is not there in the INSAT 3DR, but in the future hyperspectral sounder we are going to have this kind of accuracy. But anyhow, this is so what I was talking about earlier. Part of this thing is a 500 millimeter ridge. So this ridge, see this is a ridge location at 75 degrees. So you can see the India map, and this was one of the crucial parameter for the long range prediction of the monsoon. So this dark area, can you see a dark area here? Dark line. This is the normal location, which is the, so you are having a wind ridge here, normally here and here it will be there. The locus connecting this thing is the at 75 degrees, something around Kavarati, that longitude. So if it is, so for example, in the first thing, it is this 14.5 is a normal location of the 500 millibar April ridge. But if it is south, that means the moist air, sorry, the western westerlies have come deep into the Indian Peninsula. So that's the reason. So those years where the location is south, here the ridge location is something around 10 degree or so. So the monsoon will become bad, or monsoon will be not good. This is one of the studies they have done, and this is what apply for long range. But suppose the ridge, this is a ridge, and ridge, if you can see in the second graph on the right side, this ridge, if it is north of the, that means the westerlies have gone, upper air westerlies from 500 millibar has gone to further middle latitudes, and the easterlies or the southwest monsoon, southwesterlies have already started. So in this case, the the monsoon would be better or good. So this was an important parameter in the long range prediction of the monsoon. So this kind of ridge you can make using the geophysical height, because this is a high pressure clockwise. You can say clockwise. The geophysical height will be high over here, so you can map this ridge along the locus. So this is a very important paper, and which has been used for the medium range, for the long range forecasting of the monsoon. So Banerjee's paper is, I have not written the paper name, but it is very useful. So this is a typical example. Recently, I requested somebody from Dr. Mann from, so he has given, I told for this particular day, you can see this is a TIR of 26 October 23. And I see, you can see two patches of the convective system over Kerala as well as by the evening 5 o'clock, and also something over the Gujarat. This part, this is a western disturbance, as Ashim Mitra has told. This is a western disturbance which is moving from the west towards the Himalayas, and this is the so this is around the peak if you see over Sri Lanka, and this is around 5 o'clock in the evening. And we had a tremendous rain over here. I am at present in Kerala, what I'm speaking from. So I thought, why don't you take this one? So you can say this is a 3DR geophysical height. You can say the slight violet cases are there, then blue. So the geophysical heights are becoming slightly higher by the evening. By the low pressure, because of the monsoon. Because of the convective clouds, it is becoming lower, lightly become violet. You can say some violet color. So whereas blue is basically slightly geophysical height is high. These are high pressure zone. So this is one example I just told, recent example. Of course, another parameter. So two parameters, one geophysical height. How I have asked you, I told how the geophysical height is used to get the indirectly the 500 millibar ridge, which is useful for the monsoon. Next is the layer precipitated water vapor. So from the GPS radios on day one, if you want to get the total precipitated water vapor, you have to integrate from P1 to from surface to the upper level. So this is a Q. Q is actually specific humidity by G into dP, the layer. So you can get either layer or total. In one short sentence, I should say the total precipitated water vapor of the atmosphere. Suppose 1 square meter or square meter area. If you compress the entire water vapor present in 1 square meter to the surface, whatever the height occupying, for example, that will be the precipitated water vapor. For example, the tropical region, it can go up to 70, 80, 90 also, highest total needed water vapor. Whereas it can be as low in the drier region, especially in the deserts, it can go up to 10, 15 like that. So for any kind of convection to take place, the humidity plays an important role. Because any parcel, if you assume any parcel, which is is normally lifted adiabatically to the lifting condensation level, because of the water vapor present, it condenses and releases the latent heat, and thereby the convection, then thereby it goes according to the saturated bed. That means the convection or it becomes lighter. So the air mass property changes with the humidity. So humidity is one of the important parameters I stressed. So the layer precipitated water vapor is always an indication where the total needed water vapor is high. There is always a possibility of a convection to take place. So these are some 3 layers, the 2025 accuracy, all this I have put, and comparison methods from the other operational reduce on day, global GPS and or GPS receivers, or even microwave ground-based microwave radiometer, which gives the temperature and humidity profile, and also GPS RO technique, which gives the. So this all comparison we can do for temperature. For humidity, we can have the dual frequency sensor. So the 4 to 6 millimeter of this TP bias armature is 4 to 6 millimeter with 1 millimeter, as this was the requirement by IMD. So in fact, we have made the software. So now it is running for the INSAT 3DR, which is giving the layer precipitated humidity also. So because I was involved in before this algorithm development, I was the project manager for this. So in fact, at that time we did not have the temperature humidity profile. What I did was the temperature and humidity from the MODIS sensor, which was having one of the best at that time. We evaluated the software by making a comparison between the total precipitated water derived from the SAC and with the MODIS. So it was very good algorithm testing those time, probably in, I don't know, 2013 or 14, wherever the algorithm. So that is done. So this is a little old one. Of course, this is from 3D. Now 3D is not working, but some of the skin temperature, total precipitated water vapor. This I told no. This wherever the convection is there, 40, 60 millimeter, here is the convection is there. Ozone is also a part of the sensor in the derived product. Ozone is total ozone, or directly compute from the 9.6 channel, and then lifted index. I will be talking about this lifted index, one of the important parameter, especially in the tropics. So this is actually the TPW, total precipitated water vapor millimeter. This I have seen. You can say comparison between comparison. It will be a comparison between the MODIS derived TPW and the INSAT 3D. So we did a comparison. So MODIS 850, of course, the timing is slightly different. So it is MODIS is at 850, whereas INSAT 3D is at 8 hours GMT. So this comparison. So now I saw this 3DR automatically generate this kind of. So this lower portion where the this is the total precipitated water vapor. So you can say the total. Okay, this is TPW. Okay, not LI. This is TPW, and you can say the region of the Indian region you are having, as I told you in the first map of this October 22nd, these regions are basically drier regions, and whereas this red and yellow regions are where the TPW is high as 60 millimeter, okay, or 6 gram per centimeter square, either way. Now, this was one of my pet work which I was doing when I was in SAC, Ahmedabad. The total integrated water, now as just I told, like the 500 millibar, another application of the total precipitated water vapor is the prediction of the onset of the monsoon. So I have been doing this prediction of 2006 onwards, even up to 2023. Last year also we did. So this region which I shown is basically the Findlater region, the southwestern Arabian Sea. The water vapor built up just before the onset. That means around 18 days before this particular graph, light green graph, the water vapor, which is basically nothing but the low level jet area. So there the water vapor buildup takes place drastically from. So we try to monitor from 10th May onwards what is the total indicator water TPW, all this region, and then normally it takes 18 days for the if the peak comes in this box, and also we see the adjacent box also, and we see the other parameters. So you see the other satellite data also to see whether the onset can take place. But Arabian Sea and Bay of Bengal cyclones will disturb this water vapor pattern, TPW pattern. So thereby it should be cautioned that in case of cyclone during the onset time, which happened this year also, this our method will not able to give. But otherwise, it is giving a very good idea. This is a 2018. We predicted the updated the weeks on 11th May, and we predicted the onset will be here on the left, on the right corner. You see 29th May plus minus 2 days, you can have the onset. And the actual onset came on 29th May. That is wonderful. And many years, almost you can say so many things, almost every year, except for 1 or 2 days, years, where the cyclone is there, it is all coming on target. This has been published in Current Science. And I can say we don't not only see the integrated water vapor, we see the pattern of the 850 HPA wind during this is actually each pendant 1 to 5 like that. It is 29 to 30th, 25 to 30th May. See the typical what is it 850 HPA wind pattern coincides with this kind of thing, the 29th May. We also see the Madden-Julian oscillation. Madden-Julian oscillation is average from plus 5 degree north to minus 5 degree north. So there we see there is a periodicity right from January, right from the onset time. You are having a just few days before the Madden-Julian oscillation starts from the west of Africa, and it propagates towards the eastern part. So this is also, so we search for the total negative water vapor in the adjacent boxes and also in the Western Arabian Sea. Plus we see the wind pattern, we see the movement of the Madden-Julian oscillation finally, and this is the onset day on 29th May. So this is the typical case. Now I have transferred the whole software to SAC Ahmedabad. So now my colleague Dr. Sukanto is now doing it. So he also, I told him, so on 22nd, he used the idea. Same left side, you see the Western Arabian Sea and the peak, same box where the initial peak before the 10th May we don't consider. After 10th May, you see the peak has come. Immediately he told it will be 18 days. And he's predicted the prediction of monsoon onset on 27th May. That means this is on 11th May. No, this is sorry. Okay. This is TPW on 9th May. So 9th May plus 18 days. That is something around 27th May would be the onset. We also see the what do you say, the MGO. Also we see the wind reversal at the equator because of the strong after the peak of the rotary appeared. So exactly the actual monsoon what happened is plus minus 4 days. 27th was predicted, 29th it came. So now I'll say this kind of thing have folly in the basically in the Bay of Bengal Arabian Sea cyclone. This time Biparjoy has come, cyclone has come. So initially we thought the monsoon onset would take place. This is a case for the 2023. Okay, wrongly put on 22-23. Sorry, 22-23 is there. The same thing, but 29th May was 22nd. And 23rd, it was around, 11th May. So we thought the onset would be occurring around 29th May plus minus 4 days. But however, the Biparjoy came, the cyclone came, and this entire water vapor buildup of the total near water vapor. But surprisingly, when I again saw, again, this because it's subdued after the monsoon, another peak of the total integrated water vapor, which is something around 60 million, 55 to 58 millimeter came up. Then I just, for curiosity, I saw 18 days, exactly the onset would have been occurred on 9th May, sorry, 9th June. That means some, but the actual onset year or declared on 8th June. So it is still, once you monitor, it will be useful. That's what, so this is second parameter I told, with the total near water vapor. Okay, now the stability. Now we have come to the third parameter, which is the index. Before knowing the lifted index, one should know what is the stability. Stability determined by the lapse rate of the parcel with the environment. So, so we can say a parcel, the red color indicate the environmental lapse rate, and orange color indicate the moist adiabatic lapse rate, SALR, and green indicate the dry adiabatic lapse rate. So a given parcel means the air mass, which is having characteristic temperature and humidity at 1000 HPA. If suppose this condition is there, where the environmental lapse rate is very high, the parcel will go directly up. This is one. Suppose in the case, this is the case of an unsaturated parcel. Okay, parcel. But in case of a saturated parcel or parcel which is not dry, which is moist, in this case, initially it will lift up to the lifting condensation level. From there, because of the condensation of the water vapor, air parcel will become dry. Or the dry, this is the moist adiabatic lapse, right? It will go according to moist adiabatic. So so this is the kind of happens during for a parcel with actually saturated parcel. This is what happens. You are having a lifting condensation level, which is the base of the cloud. Then there is a level of free convection where it touches the thing, and from there on it will go by itself. Actually, okay, this is one idea. Then suppose neutral stability. The parcel having given a temperature, and if both the dry adiabatic and lapse rate in the middle level is same, so there is nothing happens to the atmosphere. It will remain as it is. This is called a neutral stability. Now, in the tropical atmosphere, normally you have the conditional instability. So a given parcel will not be saturated. So it will be almost like the unsaturated parcel. But if you having a particular temperature and humidity, so it will move according to the dry adiabatic, which is 10 degrees centigrade per kilometer. And then as soon as it reaches the place of lifting condensation level, all the air that the water molecules condenses and release the latent heat, and thereby the parcel become brighter, and it will go up to LFC. From LFC onwards, it will go by its own force to the. So you are having a condition called conditional instability. A parcel is initially dry, it becomes moist after the lifting condensation level, and then it moves. So this is a very classical example. All these things you should understand if you want to have an idea about the thermodynamic structure which is happening over the atmosphere. So in this is another case where a whole parcel, or you can say full parcel, whole parcel is not parcel, it's a whole layer get. Suppose parcel A is at a lower, at some dry adiabatic value, temperature humidity, it will move according the lower portion of this whole will move at the dry adiabatically, and it will saturate and it will move into A dash. Similarly, B, it will take a little B part of the whole thing will go up to here and it will become saturated, unsaturated, saturated, and so you this kind of atmosphere, when the whole area get stability, we will get this kind of thing. Now, how you calculate the from the INSAT 3D? Lifted index should be obtained from with the input as a mean pressure, temperature, moisture. So what you see normally, and this is also a program we have developed, we have put in the software, we have put, whereby the lower 100 HPA, that is the lower 100 part of the boundary layer, we average out the temperature, humidity in the lower 100 meters, not 100 millibar, 100 meters. You average the whole parcel is then lifted dry adiabatically to lifting condensation level. Now you understood what is lifting condensation level, the base, cloud base, and then it becomes condenses and the moist adiabically into further height, and then it is still. So if you see this one is moist adiabically up to 5. This is up to 800 only. The moist adiabically up to 500 HPA. So the environment minus parcel will be dry. So here T, the environmental temperature minus parcel will be higher, and it will become more negative in case Li will be more negative. The environmental temperature minus parcel temperature at 500 HPA is computed. And then we find out the more negative, the more instabilities, and more positive, more stabilities. So in the Indian region, lifted index is one of the important parameters we have seen, but it depends upon season, it depends upon place, location, and it depends upon so many other things. So this is before the launch of the satellite. Probably I was there at that time in SAC. So we compared with the Moody's data. It is giving quite good. Our software and the Moody's software matched very well. So this is some of the thing afterwards we saw, but we are having a wide scatter. Because the important wide scatter is because the temperature and humidity should be within 0.5 to 1 degree K, and humidity should be within 20-25%. So that is one thing. Then we are having the mesoscale convective systems. Some various parameters are there. This I'll be talking you for the mesoscale system also. So I will skip this thing. So this is one of the important, only to tell that the lifted index and humidity index are two parameters one has to look for to see in the Indian context. Okay, this I know I will be covering the mesoscale. I am skipping these two. This is a lifted index from 29. This again one with the Moody's, not the same time. Moody's and the INSAT. You can say the lifted index is more negative here. That's a blue color here. So, but of course it is high. So this is a case where now this is a case where I will show you. Again the same on 28th November. No, 28th November. No, 28th November. Sorry, 28th October. You see over Sri Lanka, and this has happened. This kind of system got developed and was peak at 5 p.m. in the evening. So, and you see this lifted index here, it is of course because the temperature profile could not be determined when the cloudiness is there, but still you can see this more negative, minus onwards. And you say this also in the Gujarat side, you can see that it is more convection is there. So this kind of thing can be determined. Now, I'll be talking about now our spaceport. What happens now? This same software, we are having a thermodynamic diagram developed. It is already given to IMD. So we have developed this thing over SAC, and we try to give this our input. We use we use this WRF forecast, temperature humidity forecasted temperature humidity profile, which is giving at 5 km at SHAR to know about the within 45 km of SHAR. So before any launch take place, this WRF NWB model is run with at 0 GMT initial GFS data with ISRO AWS, Kalpana AMV, and so many other things, radio sound days, and at NAR as well as at SHAR, we are having every hour radio sound day, GPS rotation report. ATOVs and IRC profiles and graph reflectivity. All this goes in the model, and then the temperature humidity profile is forecasted. From the temperature humidity profile is forecasted, we calculate the thermodynamic angle. That I'll be showing later on. But what we look for that SHAR is probability of development of a low pressure system in Bay of Bengal, probability of cyclone within 200 kilometers of Sierra, that is okay, and the possibility of rain intensity, because once fuel is put in the rocket, then we should not have lightning and all should not be there, and then heavy rain should not be there, because it will be a problem. And then if there's visibility, then we are expecting maximum wind. This 1.5 kilometer wind is important, but most important is the 20 kilometer wind speed. Wind speed in the lower level and tropical easterly jet. Normally, what happened? This forecast, if you are having a 9 GMT forecast, 0 GMT you start running the model, and 9 GMT you get the forecast of the wind, etc. All the parameters you get. So it should be that very high wind means even the rocket can go into two pieces. So that is very important. This this 20 kilometer wind is very, very important. So this is a typical case. Using this our own software we developed for the INSAT 3DR. We gave this to the people concerned in the NWP, and they every 3 hours, every 3 hours, using the NWP forecast, they computed the Tephegram. Tephegram is a thermodynamic diagram which will tell you about the convective available potential energy, CAPE, KINE, and LFC, LCL, and so many other parameters. So this case, the launch took place at 9 GMT. This is, I don't know which, okay, the GSLV rocket launch, 9. So you can say the forecast, this is at 6 GMT, then 9 GMT, the SHAR is SHA or SHAR is, then it's clear. And if you see the CAPE is around 1034, and around 9 to 12 GMT, it reduced to 537. If the CAPE is about 2500 or 3000 joules per kg, then the launch, it will be a problem, because you are going to have, this is one of the parameters, there are many parameters, accordingly they will see. So basically in the rocket nozzle, there's a computer, so all the temperature humidity profile and all, especially from the radio sound or GPS one, they are fed into the onboard computer in the nozzle of the rocket. And then it is the projectile is it do adjustment depending upon the the winds on those levels. Then there is something called dry microburst index. These are basically in situations characterized by high convective cloud base and strong evaporation cooling in the subcloud layer. Basically, what happens, especially in the places where there Rajasthan, mountainous region, and then the Western Ghats, and also some plains. What happens? This from the CB clouds, the rain falls from the CB cloud, vertical development. But sometimes what happens? This rain does not reach the ground. Rain does not reach the ground. It gets evaporated. So what happens? Evaporative cooling will happen, and then there is a sudden downdraft. So this can be obtained using the INSAT 3DR type of thing, or maybe future the hyperspectral sounder which you are going to be planning. There also the same procedure will work. Now these are all experimental products which most people have done the same formula. One has to do the validation and see these parameters. The only way to see is using the Doppler weather radar. So here we are using the lapse rate, T minus TD as usual, and the condition should be dry. T minus DD at 700 HPA should be greater than 12. Okay, T minus DD is equal to 8. Drier होना चाहिए नीचे में, that and it should be saturation at the upper level, so that the water rain evaporate. So this kind of there are two type of macro. One is called a macro based index, which is above greater than 5 kilometers, lasts for an half an hour, 0 to half an hour, and micro based is basically dry. It is less than 4 kilometers, and it lasts for 5 to 6 minutes only. But what happens when microbes happens over a airport? There is a downdraft, severe because of the liquid cooling. The downdraft can even happen with the when the downdraft can be 10 meter per second. Suppose it will be, if it is the downdraft is greater than the ascent rate of the aircraft, the flight will come down. Similarly, while the aircraft is landing. So typical case in the Mangalore, the tabletop disaster, maybe it is maybe due to some downdraft which is happening over the mountainous region, whereby a severe downdraft created the problem. So that the aircraft was not able to be controlled. So this is a case. So these are all we say typical. This is basically if a ghost, the red color it is indicating the dry burst. Most dry burst possibilities there. We can overlay on a IR map. Okay. So this is the dry microscopic index. Of course, we are not having much. Of course, it is happening over the not on this place. This is from the INSAT 3D. It is October 26th. So micrometer index, but of course it is very small. It should be of the green color. Then only there is a possibility of it. Green to red. If you see the earlier one, red. So that is a value. So similarly, we are having wind gustness can be also calculated. Derived parameter using the momentum continuity equation, and we are having this formula for that. Wind max provides guidance for maximum possible wind gust that can occur within the atmospheric condition if convection were to occur. It is useful for generating short range wind forecast. So this is another case of wind index which is plotted greater than 50 knots places red. These are a possibility where there is a strong gustness of wind. It is very important, for example, for the aircraft, especially for the fighter aircraft. These days we should have good kind of, but the only way to validate is using the Doppler weather radar. Okay, this is again wind index. This wind index for different different resolution. Again, the same thing I told. Then there is something called theta E differential. For any theta E is actually called a potential equivalent temperature. A parcel, especially a saturated air parcel, when lifted till the point where the till the mid tropospheric level, all the water vapor is condensed out, and the equivalent potential temperature was the difference because from surface to mid tropospheric theta E. That is giving an idea about the convection. This is another parameter which is being derived. Oh, this is a typical graph. When I was for my promotion, also this question was at that time INSAT 3D is in the shell. So at that time, my idea was any oceanographer or ocean bound ship, click at the spot, this taphogram will come out. Even this red color is indicating the radio sound station, and each blue dot on the ocean, which or in the here also Himalayas also, will the basically temperature humidity profile is the only input required. Accurate temperature humidity profile is only required to get the taphogram. It is already probably running in IMD. This and this being utilized for the launch purpose also. Okay, and this hyperspectra that I will just only touch upon the hyperspectra are the future part of our IR sounder. This probably Taplial would have already taken, so I will not touch upon it. This is the future. Only one last case I will tell you about Sri Lankan before ending my lecture. This is before ending my lecture. This is a Kalpana-derived brightness temperature data. This is on 16th April 2011. You can see the red color is the place where there is nothing is there. The brightness temperature is very high, no convection taking place. Even here, that is morning 5 o'clock. Even Sri Lanka, there is nothing. Okay, and by 12 GMT, that means exactly after 6 hours, 12 GMT, the huge cloudness over Sri Lanka you see the Sri Lanka here. So the cloudness suddenly appeared. This is actually the month of April. So April pre-monsoon thunderstorms happens that time. So this you can say very interestingly, the lifted index was minus, I don't know, -7 or 8 or the blue. This lifted index and TT. There's a total index is which is nothing but the cross totals and these are all. So that also was which is within the parameter. And then we are having the K index, another index, but and total precipitate water. You just see the total precipitate water is very high of 70 millimeter or so. So this happened. This whole graph is 6 hours before the actual onset. See, this is at this time when all the parameters can be derived. Okay, this is from the not the this is from actually from the not the this is from the Moody's Terra and Aqua. Okay, Terra and Aqua. So so this indicating that cyclone. So this is again, I said about any of this. I'll be talking about the Mazursky system. Humidity index, which is nothing but the T minus TD 850, T minus TD into 750, T minus TD 7. So the humidity index of less than 18, 18, maybe 17, 18, or 7 or 8. You are 100% sure this. So in the tropical region, both the humidity index as well as the lifted index are the most important parameter. And you see, as you see, the see this is a thing, IR picture. You can say during the 12 GMT, you can say this absolutely this Sri Lanka huge rainfall happened. So if you are having this 6 hours before, if you can get all the parameters, it is a very good indication. But you should have a season dependent coefficients for the lifted index, TTD index. Okay, thank you. I try to rush the last part. Anyway. Okay.
Thank you, sir. Lots of products information.
Any questions?
Yeah, there are.
Yeah, questions are there. Just
Questions, answers.
yeah. Yeah, so there are a few questions from Mr. SBJ Kumar. I'm reading one by one. The first question is, how do the geopotential height anomalies help in foreshadowing breaks, hiatuses, and abrupt sluggish phases of monsoon?
No, once more. Can you ask this question? Okay.
Yeah, how do the geopotential height anomalies help in foreshadowing breaks, hiatuses, and abrupt sluggish phases of monsoon?
And geopotential height is normally seen not during the monsoon. It is seen during the month of April. Geopotential height is indicated. Geopotential height will be high over the Bay of Bengal and Arabian Sea, and you will have two blobs of high pressure zones over Bay of Bengal and Arabian Sea. The locus connecting is the ridge. So location of the ridge, if it is the northern part, there is a possibility of a good rainfall, seasonal rainfall, IMSR. And if it is south, if it is in north, it is a good rainfall. And if it is south, so this is nothing. It has geopotential height is largely used for the forecasting purpose in the middle latitude because it gives the wind sources and sinks of the moisture. Okay.
Yeah, another question is, are there any threshold TPW value ranges for deep convection and monsoon onset events? In the same way, we consider the OLR range values to identify these zones of convection and convergence.
Normally, my experience for the last 2006 to something like 2023, so many years, the total integrated water vapor over the Southwest Arabian Sea, it will be around 55 to 60 millimeter when the peak occurs 18 days before the onset of the monsoon. And it has come on, as I told you, during cyclone, it is not able to give correctly. But even in cyclone, like Piparjoy, it has got a typical peak some other time. Okay.
Sir,
Yeah, thank you.
one request.
Yeah.
Close the PPT.
Huh?
Yeah, you stop sharing, sir. Yeah.
Stop. Okay. How to come out of it? I don't know.
Stop sharing.
I'll put. Okay. I'll close it.
Yeah.
Okay. Okay.
That will not help. But stop sharing.
Huh?
No, that will not help. You
So
have to
there is
stop.
a button named stop sharing.
Share screen को click करके वहाँ पे stop sharing.
Huh? When it's
The
not
button-
coming.
I think
Share screen.
शायद ऊपर होगा bar.
upper red button should be there.
हाँ.
Ah, stop. Okay. Done.
Yeah, now.
Oh, sorry. Sorry.
Yeah, no problem, sir.
Hmm.
Yeah, there is another question. If there is a cyclone as monsoon onset vortex near to the coast, it should not destabilize the monsoon onset process, but a TC forming just before onset over southeastern Arabian or west of it and moving north or northwestward would cause such a havoc with onset process. As rightly pointed by you, sir, in case of recent pre-monsoon Arabian cyclones such as Biparjoy, Nanok, etc., kindly enlighten me with satellite perspectives.
Yeah. See, as I told you, for the onset, I have to shown the graph whereby I am taking the total perceptible water vapor over a large area. That is from 0 to 10 degree north and for something like 40 to 60 degree, 65 degree east. That what do you say? This low level jet area is very big. So there I am seeing the indicated water vapor is reaching up to 60 millimeter about 18 days before. But during cyclone, what happens? When the cyclone in the Arabian Sea comes, it completely picks up the whole moisture, and moisture is no longer available. This is what happened in the Biparjoy case. Then it indicated before the cyclone came, it was indicating a peak on 11th of May, and we thought the onset will happen 29th. But then cyclone, of course, we are given the thing when cyclone comes, it is not possible. Then the cyclone has sucked up the whole moisture, and it took time for the actual onset to propagate further north.
Thank you, sir. There is another question by the same person.
Hmm.
Can dry microburst be linked to clean air turbulence at higher levels?
No. Dry microburst is nothing to do with the clear air turbulence. Clear air turbulence are totally different. This is clear air turbulence are due to similar to mountain waves. In the case of clear air turbulence, in the mountain waves you are having mountain as a barrier. In the clear air turbulence you are having that either it comes to the jet stream or some kind of thing whereby such kind of turbulence even without air also you may have this in the aeroplane where you get sudden bumpiness even without any cloud. That is nothing to do with dry microburst index. Dry microburst index is when it happens in the lower area associated with the CB cloud, on the base of the CB cloud, when the rain get evaporated over a desert region or a mountainous region, this sudden negative buoyancy comes, which is some very disastrous. Probably it is having even a negative buoyancy of 10 meter per second, which is greater than the ascent rate of the aircraft. So this is a great. It is nothing to do with clear air turbulence.
Okay,
Yes.
thank you, sir. Now there is no further question. I'm not seeing any further question.
Okay. Thank you.
Yeah,
Thank you.
over to you, Dr. Rohini.
Okay. So thank you, sir. Let's have a photo session. I request all the panelists to switch on their cameras. And I request Dr. Swagata and Dr. Ajit sir, Tyagi sir.
Tyagi sir, please.
Is done.
Is done. Okay. So let's proceed to vote of thanks. I request Dr. Mohan Das, who is Joint Secretary Sabha from Naomi, to conduct the vote of thanks.
Dear esteemed participant and guest, it is with immense joy and gratitude that I extend my sincere thanks for your participation in the remarkable 12th lecture of our Satellite Weekly online lecture series. Today we had the distinct privilege of immersing ourselves in the world of infrared sounding products from satellites and their applications, skillfully presented by the esteemed scientist Dr. Baby Simon, Scientist G, retired from Atmospheric and Oceanic Science Group from the Space Application Center, Ahmedabad, India. Let us take a moment to applaud and express our deepest appreciation to Dr. Baby Simon. His presentation was not only informative but also a source of inspiration, enriching our understanding of infrared sounding products and their diverse applications. Dr. Simon's commitment to sharing his expertise is truly commendable, and we eagerly anticipate the ongoing enlightenment that his contributions bring. A special thanks are extended to our esteemed SAMA Executive Coordination Team members, Dr. Rohini Bhawar and Dr. Mili Ghosh Nilala, for their exceptional efforts in steering the session, introducing the speaker, and fostering a meaningful question-answer dialogues and moderation of the sessions. Their dedication has consistently crafted an engaging and enriching learning experience centered around the intricacies of satellite applications. To all the participants and attendees, your collective engagement from various corners of the world has added depth and diversity to our discussions, making this program an unquestionable success. Your enthusiasm is the driving force behind the collaborative spirit of learning that we hold dear. In conclusion, we express our deepest gratitude to the key figures who paved the way of Satellite Weekly Lecture Series: Air Vice Marshal Retired Professor Dr. Ojit Tyagi, Chairman of SAMA, Professor Dr. Someshwar Das, General Secretary of SAMA, and Professor Dr. Swagata Paira, Treasurer of SAMA. Their unwavering support and great guidance continue to be the cornerstone of our journey into the realm of infrared and sounding products and their applications. Thank you, and may the insight gained today be a beacon for future enlightening sessions. Together, let us persist in exploring the fascinating world of satellite meteorology. Thank you very much. Thank you all.
Dr. Mohan, I hope we can conclude this session. Permission of Tyagi sir and Commissioner Dasan.
If Rohini's voice is not working, Millimum, you can continue. Yeah, Millimum, you can continue.
It's not?
Yeah.
Yeah,
Yeah,
Rohini,
that-
your voice is not coming.
Now it's
Mili,
okay.
Dr. Mili, you can continue.
Yeah. Yes, sir. Thanks a lot, sir. Again, Dr. Simon. And any words from Dr. Tyagi, sir, Dr. Bhatia, sir, and Dr. Someshwar Das, sir?
Bhatia Sahab,
Sir, if
next week is your lecture, right? Bhatia
Yes,
Sahab?
yes.
Great, great. So,
Next week is
yeah, so I'd like to remind. So very interesting talk, Dr. Simon. Really very good, and so many convective parameters can be retrieved through satellites, as you have said, and also the profiles of the diagrams. It was all developed by you, right? The inside 3DR diagrams at various points over the Indian region, whereby we just moved the mouse. I remember. And then your mic is mute.
Only transfer to IMD.
Yeah, I know.
Uh-huh.
But it was very, very good
Yeah.
application software that you have developed. Because so interesting, just move the mouse and then it will show the
Correct.
profile.
Yeah.
But I wonder, all those profiles, why it was not simulated in the NWP? Because it was
Tell me, what is
in
it?
the NWP model.
Uh.
At that time, those profiles were not assimilated. Only the radiances were assimilated, right? We were not assimilating those profiles.
That is because radians are better accurate than profiles. Because as I told you, the accuracy just now recently on the paper we saw that the profiles determined from the INSAT 3D was having some inaccuracy. Because this is in India only, this is the only nation which is having the 8 sounder, which is now even GOES is also not there. They are all going for hyperspectral sounder, where accuracy will be better. MODIS type of sensor is now is the very good actually. 1 kilometer resolution for mesoscale studies.
What is?
Actually, I'd just like to add one point here that once this hyperspectral sounder era began, now that in the 10 year, 15 year back, after that, even our forecasts are very good. After this inclusion of radiances from a hyperspectral sounder, so your forecasts are even within 1K or better than that. So even if you put, if you try to assimilate insert 3D or multispectral sounder radiances, they get rejected. But they are still useful because this geostationary sounder is the only sounder which can provide you sounding every 1 hour. So whenever there is an extreme event like thunderstorm, prior to thunderstorm, so those type of high gradient in this Lipton index cannot be picked up by forecast. So it is only useful for nowcasting. But for usual this estimation, if you try radiance estimation, so it will not be that much useful. But now, future, we are going for 4th generation insert satellite, where we will try to have a hyperspectral sounder on onboard geo platform.
Yeah, that will be great.
Yeah.
And then, of course, besides assimilating those data in the model, which is anyway assimilated through the radiance, but if we want to utilize those profiles, especially those indices for the microburst and other convective indices, that will be very, very useful for studying at least the post-mortem of the severe storms that might have occurred in the mountains, especially in the remote areas where there is no access or there is no availability of the radiosondes. Also, it has got a great advantage compared to the LEO, right?
Yes.
Yeah.
LEO also,
temporal is very good.
yeah. So LEO and even the MODIS also, for example, I mean, it is not continuous. It just passes once in a while.
Yes. Only four passes are there. 2
Right.
by Aqua and 2 by Terra.
MODIS is actually a pseudo sounder. So the only advantage is it gives you a high
resolution. Yes.
But otherwise, if you are having JPSS CRIS hyperspectral and then mid-top ERC hyperspectral, so every day, morning, evening, and noon, midnight. So 4 passes you get from hyperspectral sounding. So those are they are providing very good radiances for assimilation in NW models. So even after that, you try to assimilate any other sounder assimilation, multispectral sounder radiance, that will not get assimilated. Only when there are extreme weather events, prior to thunderstorm or prior to whenever there is this inversion, temperature inversion, those type of events can be picked up with repeated coverage from geostationary satellite. And we will also move away from this 18 channel sounder in future, because now GOES has stopped that. Even NOAA Hertz is also not because they already have a hyperspectral on LEO platform, so they have also moved away from multispectral sounder. So that's what we also will be doing in future, having advanced imager like MODIS, and as well as the hyperspectral sounder in geostationary platform.
Are there any studies using your hyperspectral sounding profile for these cloud bursts, which occur over the mountains, especially in Uttarakhand? You are from Uttarakhand, and
cloud burst you need advanced imager which can provide you the rapid changing cloud microphysics. So microphysics, how is the cloud buildup, how droplet size distribution, and those things they can be picked up very well with the advanced baseline imager. Himawari also, Himawari is having AHI towards our eastern side. So those type of advanced imager which is available elsewhere, only Indian Ocean area is right now is not covered by advanced imager. Only we have SAVIRI, Meteosat 2nd generation satellite. So those type of satellite can be useful for providing that information. But then if you want exact information about what is happening within cloud, then you need to have radar, precipitation radar. So in future, so from low inclination orbit we can have in future. That will be helpful.
Right now, is there any Indian satellite in which PR is there? No.
PR, no, not now. We now will be we can develop that, but now with the new space policy, we have to get requirement from user agencies. That is why we are now having interaction with the MOES and other agencies to propose a new instrument to sponsor new instrument that we can build and launch.
No, वो तो है ही ना. I mean, there is so much of requirement and importance.
No requirement in terms of funding. So now
Yeah,
the
I mean,
funding.
yes, there should be somebody to raise the voice. The point is that somebody
Yeah.
should raise the voice.
That's what we have started with Insert 4th generation, advanced imager and hyperspectral sounder. That has started. Now slowly we will be going to, like recently we have also got microwave humidity sounder, but that was an opportunity-based mission from micro set satellite. So we have demonstrated.
You are having microwave humidity sounder?
Yeah, we built
it is already planned, no?
It is already built and that is launched from microsat satellite, and that data is available from our MOSDEC.
Okay.
But
That is good, very good. This happened when? This happened when? I was also not
This
aware.
1 year back, just
1 year back. Okay, I am not aware of this thing.
Yeah, but this is only experimental because this gives coverage only for 15 minutes because it's a small satellite plus. No? So we only wanted to demonstrate that instrument. Now, only when users come forward, sponsor and give us funding, we can have more and more humidity sounder like Saphir. So that will be actually a very good development.
I mean, you expect funding from the user agencies or ISRO can have its own?
No. Now this has become very clear that even PM sir has told that it should be all user driven. So earlier we used, because that was our development phase. No? So for development purpose, we used to have to get funding and then demonstrate that technology. But now only once there is requirement from the users, either this meteorological department or the defense sector or any other agriculture sector. So based on that, only new satellites will be developed.
And there is one question.
The precipitation radar, has the requirement been given by IMD for future insert?
Requirement, sir, requirement will be there, but it is only in terms that we need this. But now that should be proposal, and there should be funding, like
Funding,
like
they should give requirement with the money.
Yes.
Like money.
That we got money from IMD. No? So
actually, TRMM type satellite is the most important, especially in our region. Low inclination, it should be low inclination. You should have SST as a sensor in like TRMM. In fact, TRMM is one of the best satellite which I have utilized among them. It is having is a beautiful PR radar. It's excellent.
So you may remember that recently this OceanSat 3, that was also funded by MOES, which is having a spectrometer, SSTM, and Ocean.
I don't know, it's the government policy, but the point is, if there is a requirement of the MOES, is the government taking the money from one pocket and then put it in another pocket?
And I think that is to ensure the accountability, because user want what we want, and then they will only say that okay.
Users' requirement should be there.
Yes.
And what about the CubeSat? I mean, nowadays some universities are launching the CubeSat. So
yes, yeah, we are doing that. Actually, we are doing it because we have now a small satellite launch vehicle. So that also we are testing it. That is in testing phase, and in future there will be a lot of demand from private sector, for foreign space agencies or universities to launch their own small satellites. But to test those small launch vehicles, we are putting our own microsat, our own small satellites. So that's why we say that is without funding also we can do that. So we have demonstrated a Saphir type of instrument, that microwave humidity sounder MHS, that was done just 1 year back. So that data is being utilized by NCMA developed regularly, and that is also open to other international agencies also. So it is every day we switch on for 15-20 minutes over Indian region, wherever we have coverage areas there. And that data then we can assimilate, we can retrieve humidity profiles. Now that is for demonstration. Then next demonstration we are doing for GNSS-R deflectometer. And then there may be this 1.4 L-band radiometer. So those type of opportunity we can use for demonstrating our own technology. Once that is demonstration is there through these opportunity-based missions, then later on, users can say that okay, you have this technology, so we are interested in having similar type of instrument in orbit.
some data from tropics project. Has it been used by SAC for any studies or by NCMWRF for some
Yeah, that is being used
estimation?
by
Tropics,
yeah, that is being used by Inspire Developed as well as you were also using that.
you are using it.
Yeah,
Okay.
And one question which Dr. Kelkar Saab always asks that can you measure the surface pressure from the satellite? When we
yeah, surface pressure actually that is very interesting. That we are looking into that in future. Once because recently we have an opportunity, another opportunity-based mission. So there we are planning to have a hyperspectral microwave sounder. So now for atmospheric to measure atmospheric pressure, you have to have measurement of a gas which is abundant in atmosphere. So there are two primary gases, nitrogen and oxygen. So fortunately, we have an absorption band of oxygen in microwave around 120 gigahertz and 50 to 60 gigahertz. So based on that, we are trying. We will be having in future over oceanic region at least. We can have surface